screen. Okay, so we are here, 11.2. I'm changing the assignment a little. It's going to be 1 to 30, 43, and 44. So the problems before that I included were a little bit too difficult, so I decided to throw it out. So change it a little bit, 1 to 30, 43, and 44. And then we're ready for the test this coming Thursday. Okay, so 1 to 30, I'll do close to all the evens. And again, I should hasten to add my evens, which may not be your evens, but it's okay. You're learning stuff and you don't have the answers in the back of the book anyway, so it shouldn't matter. Okay, so schedule-wise, we are here on November 17th, 11.2, and exam is this coming Thursday. Okay, so you know the ground rules. We've done enough tests. So you submit all of this. You must submit at least 70% of the homework in order for me to grade your test. But hey, I end up doing a great percentage of the problems anyway, right? What do I end up doing? 40%, 50%, maybe even more than half. Okay, so you just have to do the rest. So on Thursday, as usual, I will let you ask questions on Thursday, but I'm hoping you can, quote unquote, get it out of your system today. So I'm hoping to finish somewhat early, 11.2 today, and then the rest of today, I'll let you have for questions and answers to get as many out as possible. So then Thursday, potentially we wouldn't have to take that many questions, but you can still ask Thursday. The limit will be 6 o'clock. So I have to stop taking questions at 6 o'clock. But right at 5:40, if you're all good to start, we'll just start. And I'll project the problems, but I'll also have a chance to send it over on Canvas announcement as usual. And then you have until our usual stopping time is 6:55. And then 6:55, I'll close the meeting. You have 5 minutes to submit your exam by 7, and then you have until 7:30 to turn in the homework, right? But if you want to submit the homework early, you're allowed to do that also, of course. Okay, so that's pretty much what's happening. Okay, sorry, this might take a while, but somebody put something in the chat. Let me check. Okay, so yeah, Jonathan put the 11.2 there also. All right, so I'm going to go ahead and lecture from 11.2, and then hopefully I finish somewhat early, and then you be prepared for questions. So if you have burning questions in your mind about anything from any of the previous sections, bring that up after I finished 11.2. And you can even ask stuff from 11.2 also, and then that'll be the rest of today. Okay. The exam is just stuff that we had here, 10.1, 2, 3, 4, 11.1, 11.2. Okay. Okay, so I'm going to go back and share the screen. Sorry, there's no way to do it fast. Okay, so here we are again. Let me check something real quickly here. Yeah, that should be it. Okay, so let's get started. Okay, so I'm going to try to do as many of the evens as possible, maybe all of them. And again, it's my even, so if it doesn't match yours, no big deal. We've seen that already. Okay, so the one big new derivative was e to the x. Okay, and we know the derivative of e to the x is itself. On my page 703, the y is e to the x, the derivative is e to the x. And it also has its own chain rule, as you know. Okay. So let's just get right to it. So my page 706, 11.2. And we'll stop at problem 30, and then there's a couple of word problems. So let's jump right into it. Okay. Oh, the quiz. That's right. Quickly over the quiz. It's now too late to submit, so I can go over it. So first derivative is 450 minus 2x. Double prime is -2. That's less than 0, which means concave down, which means I have a maximum. So that proves I have a maximum. Set the first derivative equal to 0. 450 minus 2x equals 0. A little bit of algebra. X is 225. So that maximizes the revenue. What is the maximum revenue? I plug in 225, 50,625. Okay. I know some of you just submitted it. If you just recently submitted, I won't get to it until probably tomorrow, but that's okay as long as I got it. So that's it for the quiz. Obviously, we don't have a quiz this week because we're having an exam, right? So the exam will be this week. Okay. So let me go straight to derivatives involving e to the x. Okay, so 11.2. All right, so number 2, y equals x squared minus 3e to the x. Right, so the derivative of x squared is 2x. The derivative of negative 3 e to the x. So if you have a number times a function, the derivative is the number, negative 3, times the derivative of the function. But now that we know the derivative of e to the x is itself, I just go ahead and write minus 3 e to the x. Okay, so that's it. That's the derivative. Okay, number 4, f of x equals 4 e to the x minus natural log of x. And just curiosity, right now they match, it seems like, but whatever. Okay, so the derivative of 4 e to the x is itself 4 e to the x. Okay, so again, if you have a number times a function, like 4 times something, the derivative is 4 times the derivative of the function, but the derivative of e to the x is still e to the x. Okay, minus, and then from last time, derivative of natural log of x, 1 over x. So there we go. Okay, 2, 4, 6. H of x equals 750 e to the 0.04x. So here's our first example of the chain rule involving exponential functions. Okay, so it's not just e to the x, it's e to something. This qualifies as being the so-called inside function. I know it doesn't look like it's inside, but the outside function is the exponential. So when I finish taking the derivative of that, I have to multiply by the derivative of this. Okay, so h prime of x is 750, constant multiplier root. You keep the 750, e to the 0.04x, and then by the chain rule times the derivative of 0.04x, which is 0.04. Okay, then I just do easy stuff like multiply that times that, punch it in your machine. So final answer, 30 e to the 0.04x. And yeah, if I give you something like this in a test, you should do easy stuff like 750 times that. That should not be that big a deal. Okay, 2, 4, 6, 8. Y equals e to the x squared minus 1. Yeah, looks like it still matches so far. All right, so the derivative of e to something is e to something. Just copy it, times the derivative of that something. So the derivative dy dx is e to the x squared minus 1 times the derivative of this, which is 2x. Okay, and that's basically it, except normally we put the 2x in front, so I just sneak it out in front. Best final answer, 2x e to the x squared minus 1, like that. Okay. All right, number 10. Y equals 1 minus 2 e to the negative x cubed. What's the derivative? So y prime, the derivative of 1 is 0, so that's nice. Don't have to do anything with that. So what's the derivative of negative 2 e to the negative x cubed? Well, it's negative 2 e to the negative x cubed. You just copy this. And then by the chain rule, times the derivative of the exponent floating up there. So what's the derivative of negative x cubed? Negative 3x squared. And then just combine these. So negative 2 times a negative 3 is a positive 6, and that's an x squared. So best final answer, 6x squared e to the negative x cubed. Okay. All right, 12. E to the square root of x squared minus 9. Before I differentiate, and what's differentiate again? It means take a derivative. I'm going to think of it as x squared minus 9 to the 1/2 power. So a little sidebar here. Remember, if you take a square root, it means raising something to the 1/2 power. So all of these are equivalent. Square root of 36 is the same thing as 36 to the 1/2 power. Or you could even say 36 to the 0.5, since 1/2 is 0.5. And of course, we know that's 6. Okay, so e to the square root, x squared minus 9. Think of it as x squared minus 9 raised to the 1/2 power. Okay, so now I'm ready to differentiate. Come down here. So y prime is, just copy the original. e to the square root of x squared minus 9. So that stays the same. And then by the chain rule, I multiply by the derivative of this. So 1/2 comes down, x squared minus 9 to the negative 1/2. Okay, 1/2 minus 1 is negative 1/2, right? 1/2 minus 2 over 2 is negative 1 over 2. And then again by the chain rule, it's times the derivative of the inside. So what's the derivative of x squared minus 9? 2x. And then some touch up. 2 cancels 1/2. X is on top. This goes in the denominator as a square root. Okay, so x is on top. It joins the e stuff. So on top I have x, e to the square root of x squared minus 9. And then this stuff becomes a square root because of the 1/2, and it's in the denominator because of negative. So it's over square root of x squared minus 9. So that's going to be my answer. Okay, and in case you're wondering, no, you cannot cancel these. You don't cancel an exponent with something that's not an exponent. So just leave it like that.
Hello, sir.
Question, yes.
What are you multiplying the half? And then, yes, what are you multiplying that with?
I'm multiplying the 1/2 times the 2, which means they cancel out.
Yes,
2
but
times
where does
1/2
that
is
stem
1.
from?
Where does what stem from?
Where does the multiplication of the half come from?
Okay, so this is where the derivative of the exponent comes in.
Oh, the derivative. Okay, sir, thank you.
So it's a chain rule. So it's easier to look at this. So 1/2 comes in front. X squared minus 9 to the negative 1/2 times 2x. And the 2 and the 1/2 cancel out. Okay. All right, 14. Yeah, still matches. E cubed plus e to the ln x. Okay. This one, before you start, you should cancel the e and the ln. E and ln are inverse functions of each other, which means you can just rewrite this as e cubed plus x. Okay. So again, anytime you have e and ln next to each other, back to back, as it were, just cancel them out. The answer is x. So on most calculators, for instance, the ln and the e are right next to each other, which means they're inverse functions of each other. So anytime you do an ln followed by an e, or vice versa, you do an e followed by an ln, they cancel each other and just have x. So I'm going to rewrite this as x. Okay, another tricky thing is e cubed. E cubed is a real number. It's 2.7 cubed. Okay, I mean, you can punch out its value. It's rather irrelevant because it's a constant. Second function, e cubed, 20.085, whatever. It's a number. Therefore, what is its derivative? 0. So the derivative of this whole thing is just 0 plus 1, 1. Right? So it's easier than you might think. Okay, so that's 14. Let's see, I'm done with that sheet, I think.
Professor,
Yes.
can you go back and see number 14? Explain again, what is the 2.7 come from?
2.7 is E. It's the value of E. It's
Do
like
we
pi.
have to write it, the value of E also, 2.7?
No, this is for teaching purposes. Okay, it's just like if I put pi and then I put 3.14 there. You don't really need to put it. Okay. But there are students who don't realize that E is 2.7, so that's the reason why I put it down. But no, you don't have to put it down.
So the prime, y prime, 0 plus 1 is from?
Right, the derivative of E cubed is 0. The derivative of X is 1.
Okay.
So just 1. This is like saying 2.7 cubed. We saw it was about 20 something, but you don't really care. Its derivative is 0. It's a constant.
All right, thank you.
All right, you're welcome. The key for this is not to put down the derivative as e cubed. It isn't. The derivative is 0. Okay.
So
So, sir,
Yeah, question?
derivative of e to the third power is always 0.
The derivative of e to the third power is 0, correct. It's a number. It's a constant.
so for example, if that e cube had an x next to it, it'd be 1.
If it was an x, that's different. That's a variable expression. You mean e to the 3x?
No, it'd be e cube x.
E cubed times x. Is that
Yes.
what you mean? Yeah, then the derivative would be e cubed. It's just like saying 20.8x. The derivative is 20.8. All right. Okay. 16. Y equals 2e to the radical x. We can treat this as x to the half. So the derivative is the same thing, 2e to the radical x, and then times the derivative of radical x. You can treat it as x to the 1/2. Therefore, what's the derivative of x to the 1/2? 1/2 x to the negative 1/2. 1/2 comes down, x to the 1/2 minus 1 is negative 1/2. And once again, 2 cancels a half here. So they cross out. This becomes a square root on the bottom, once again. So e to the radical x divided by radical x is going to be my answer for this particular one. And you can just leave it like that. Okay, once again, don't cancel this with this. You don't cancel an exponent with something that is not an exponent. So just leave it alone. Okay, 18, I've got some extra stuff there. It starts off with 2 over e to the 2x. That arrow there means I'm going to bring it upstairs. I'm going to write it as e to the negative 2x. This one said e to the 2x over 2. In red, I stuck in a 1, and I'll treat it as a coefficient of 1/2. So I will treat this problem as 2e to the negative 2x plus 1/2 e to the 2x. It makes it much easier. Okay. Again, if you have a constant like 2, either in the numerator or in the denominator, you should not do the quotient rule. It's much easier in this case to just bring the e up, e to the negative 2x. And this one, dividing by 2, think of it as multiplying by 1/2. That way, I prevented myself from doing the quotient rule here and the quotient rule here, because the quotient rule is one of our least favorite ones. Both of these are going to be chain rule involving e, though. So the derivative of 2e to the negative 2x is the same thing, 2e to the negative 2x. And then by the chain rule times the derivative of negative 2x, which is negative 2. Plus the derivative of 1/2 e to the 2x is same thing, 1/2 e to the 2x. Again, by the chain rule times the derivative of 2x, which is also 2. Okay, and then I combine. 2 times a negative 2 is a negative 4. 1/2 times 2 is 1, so just cancel them out. So best final answer, negative 4 e to the negative 2x plus e to the 2x. Okay, and in case you're wondering, it's always acceptable to have a negative exponent on e. So you don't have to put this back in the denominator. Okay, e to a negative exponent is always okay. So we'll just leave it like that. Okay, then starting with problem 20, it gets harder because we have product rule and maybe quotient rule involved with these. Okay, so 20, P is 4Q e to the Q cubed. I'm just curious, that's the same thing here? Yeah, that is the same thing. Okay, so this is going to be a little bit harder. Okay, product rule. First function, second function. And by the way, if you want to put down the product rule, quotient rule, chain rule, if you want to put all those on your formula sheet for the test on Thursday, you may put it again. So dp, dq. So product rule. You copy the first function. Here it is, 4q. And then multiply it by the derivative of the second. So what's the derivative of e to the q cubed? E to the q cubed times the derivative of q cubed, 3q squared. And so first function times the derivative of the second, plus the other way around. Second function, copy the second function, e to the q cubed, times the derivative of the first function. So the derivative of 4q is just 4. So this is a product rule. First times derivative of the second, that's all this stuff, plus second times derivative of the first. Okay, now just a little bit of combining. So you should multiply these. 4 times 3 is 12. Q times q squared is q cubed. So 12q cubed e to the q cubed plus, and then here normally you put the 4 in front. So 4e to the q cubed. So that's my answer for that one. Okay, 22, yeah, that's the way they write it. 22 is written like this. Okay, I will use a property of exponents that when you have a power and another power, you multiply them. So x times 3 is 3x. So I have 4e to 3x minus 4e to the x cubed. So again, it's chain rule. So y prime, the derivative of this is same thing, just copy the original, but then it's times the derivative of the exponent. So what is the derivative of 3x? 3. Same concept here, minus 4e to the x cubed. The derivative is the same thing, minus 4e to the x cubed, times the derivative of x cubed, 3x squared. And then just some easy cleanup. 4 times 3 is 12, 12e to 3x. And then let's see, negative 4 times 3x squared, negative 12x squared, e to the x cubed. All right, so we'll just leave it like that. All right. 24. Now we have ln and e. In case you're wondering, these cannot cancel just because of the plus 1. That plus 1 fouls it all up. If it was just like this, ln e, cancel out the ln and e, and you just have 2x. But once you add or subtract something, sorry, you got to take it as is. So ln of something. So how do I take the derivative of ln of something? 1 over that. So 1 over e to the 2x plus 1. And then by the chain rule, times the derivative of this inside stuff. So now I differentiate e to the 2x plus 1. Well, the derivative of 1 is 0, so I don't have to worry about that. Derivative of e to the 2x is e to the 2x times 2, derivative of 2x. Okay. And we remember this theme from last time when we did a lot of natural log. This thing just slides over and multiplies by the 1, which means just move that on top. So 2 e to the 2x divided by e to the 2x plus 1. Okay, and no, you cannot cancel here. That's not allowed, right? Once you add or subtract something, can't cancel. Again, if that plus 1 weren't there like that, then you can cancel the e to 2x. But once I have a plus 1, then forget it. Can't do it. Okay, problem 26. y equals e to the 2x squared natural log 4x. Okay, so it looks like a product rule again. First function, second function. So we call the product rule fg prime is fg prime plus gf prime. In words, I say the first times the derivative of the second plus the second times the derivative of the first. First, second. Okay, so dy dx means derivative. So copy the first, here's my f, times the derivative of the second. So I have to take the derivative of ln 4x. So what is the derivative of ln 4x? Since there's an ln, you go 1 over 4x. And then by the chain rule, times the derivative of 4x, which is 4. And you can see these 4s are going to cancel. Plus gf prime. Second function, copy natural log of 4x, ln 4x, times f prime. So I multiply it by the derivative of the first function. So what is the derivative of e to the 2x squared? It is e to the 2x squared, just copy it. And then times the derivative of the exponent. What's the derivative of 2x squared? 4x. Okay, then just a little bit of touch up. Let's see, 4's cancel out. X is in the bottom. So e to the 2x squared divided by x plus, and then what did I do over here? I just put the 4x in front, e to the 2x squared, natural log of 4x. Again, ln stands for natural log or log natural. Natural log. Okay. All right, and then 28 and 30 have the quotient rule. It's one of our least favorites. Okay. But I have 28, 30, and then I was going to show you the one word problem 44, and then that's about it. Okay, at which point I'll let you ask questions. So I'll be done in a few minutes. Okay, so quotient rule. Here is the quotient rule again. F divided by G prime, right? So it's GF prime minus FG prime divided by G squared. Quotient rule. So you start with the bottom, 1 plus e to 2x, times the derivative of the top. Now the derivative of x is just 1. Minus the top, x, times the derivative of the bottom. So what's the derivative of the bottom? Well, the derivative of 1 is 0, so forget about that. Derivative of e to the 2x is itself e to the 2x times 2, the derivative of 2x. All over g squared, the denominator squared, 1 plus e to the 2x quantity squared. All right, then I just kind of multiplied this out a little. So 1 plus e to the 2x minus 2x e to the 2x divided by 1 plus e to the 2x quantity squared. Yeah, you can just leave it like that. So that's pretty much about it. Okay, 30 is a real funny looking one. E to the x minus e to the negative x divided by e to the x plus e to the negative x. Okay, so you have e's and negatives all over the place. Okay, and maybe before I tackle that, let me try to show you this. So sidebar here. What is e to the negative x prime? The derivative of e to the negative x is the same thing, e to negative x, and then by the chain rule times the derivative of negative x, which is negative 1. But if I multiply by negative 1, I might as well just put a minus sign in front of the whole thing. Okay, so the derivative of e to the negative x is negative e to the negative x. That's going to show up over here. Okay, so here we go. See, there's e's all over the place. Might be kind of hard to copy all this, or you can check the video later. Okay, so y prime bottom, copy the bottom. There it is. Even that's not that easy because you got x's and negative x's all over the place. So try to copy the bottom. E to the x plus e to the negative x times the derivative of the top. And I'm doing the quotient rule. So what is the derivative of the top? Derivative of e to the x is itself the derivative of negative e to the negative x is positive e to the negative x. Okay, minus fg prime. Top times the derivative of the bottom. So I copy the top, e to the x minus e to the negative x, times the derivative of the bottom. So what is the derivative of the bottom? E to the x minus e to the negative x. All over the denominator squared. So e to the x plus e to the negative x quantity squared. Okay.
Professor,
Yes.
excuse me. How come that the second line, the derivative, you put parentheses, plus sign, and then plus sign? Isn't it supposed to be negative sign?
Okay, let me see. Are you talking about these two here?
Yes.
Okay, so you copy the bottom,
Uh-huh.
and then you take the derivative of the top. The derivative of this is this. The derivative of e to the x is e to the x. The derivative of negative e to the negative x is positive
Oh,
e
okay.
to the negative x. A little bit tricky.
The negative and negative is positive. Okay.
Yeah, I'm taking advantage of
Right.
this thing here.
Thank you.
Okay, you're welcome. Now, this gets a little tricky. This is the same as this. So I'm writing it as e to the x plus e to the negative x squared. This is the same as this. So I'm going to write it as e to the x minus e to the negative x squared. Which means it's of the form a squared minus b squared. This whole thing is like my a. This whole thing is like my b. A squared minus b squared. A squared minus b squared factors into a plus b, a minus b. That's what I'm trying to do here to clean up this mess. Okay, so one more time. This parenthesis and this parentheses are the same. So it's squared. These two are the same. So it's squared. So it's blah, blah, blah squared minus another blah, blah, blah squared, a squared minus b squared. So I'm going to try to do a plus b, a minus b. So it's this, e to the x plus e to the negative x, plus this, e to the x minus e to the negative x. And then I multiply it by a minus b. So e to the x plus e to the negative x minus parentheses e to the x minus e to the negative x all over e to the x plus e to the negative x quantity squared. Okay, it's a big mess. That cancels that. E to the x plus e to the x, 2 e to the x. This e to the x cancels that e to the x. E to the negative x, that's a negative there if you can't see it. It gets kind of small. This is e to the negative x minus a minus e to the negative x. That's like e to the negative x plus e to the negative x, 2 e to the negative x. This times this is 1. E to the x times e to the negative x. I'm supposed to add the exponents. That gives me e to the 0. Anything to the 0 is 1. So I just have 2 times 2, which is 4 on top. And I ran out of space, so I'm going up here. So finally, the final answer is this. 4 over e to the x plus e to the negative x quantity squared. Okay. So that one was a mouthful, as you can see.
Professor,
Yes,
Is-
question.
so can you, what is that? What is the sign on the A minus B? EDX plus ED.
This one here,
Yes,
e to the x plus e to the negative x.
negative X.
and
Okay.
this minus e to the x minus e to the negative x.
And how come the other one is not on the left? This is negative X also, the first one.
Correct. This is negative x, and that's also a negative x.
Oh,
Maybe
this is
both of them.
negative X also.
You guys should put a
Okay.
negative there. There's supposed to be a little negative there, but it looks like it's part of the x, unfortunately. When you write
Okay,
so small and something like that.
thank you.
Okay, you're welcome. Okay, 44 and I'm done. So in a couple minutes I'll be done. Then I'll let you ask questions from anything here. Okay, so you can have those ready. And again, the more questions we get done today, then the fewer questions we have to take Thursday before the test. So that gives you more time for the test, okay? Okay, so 44. And it does look like it matches, I hope. Yeah, it matches, I think. Okay, future value, blah, blah, blah. S of t is 700 e to the 0.09 t. And what rate is the money in this account growing when t equals 4? Take the derivative, plug in 4. Part B, at what rate is it growing when t equals 10? Take the derivative and plug in 10. Okay, so that's all that's happening there. So 700 e to the 0.09 t. So S prime of t, the derivative of 700 e to the 0.09 t is the same thing, 700 e to the 0.09 t. And then by the chain root times the derivative of 0.09 t, which is 0.09. And then I just multiply that times that, comes out to be 63. So 63 e to the 0.09 t. And now it's very easy, it's just a plug in. They say, at what rate is it changing, i.e. derivative, at t equals 4 years, plug in 4. So 63 e to the 0.36, punch it in the machine, $90.30. Again, for most of your calculators, to get the e, you have to do the second function, right? Whoops, right here, right? So I have to hit second function, e to the x. If I don't hit the second function, it'll just do ln for me. I want e to the x. Okay, then part B, same thing, just plug in 10. So 63 e to the 0.09 times 10, which is 63 e to the 0.9, punch in a machine, $154.95. Okay, and maybe just to show you one of them, see, 63. Okay, so again, to get e, second function, e to the x. So second function, e to the x. And what was the exponent again? 0.9. So let me do that. Trying to aim it so you can see it without my burning out your eyeballs. Whoops, sorry. 63 e to the 0.9. Whoops, sorry. There we go. 154.95 looks like. $154.95. Okay. Now keep in mind, some of your calculators go backwards. If you have a regular scientific calculator, you might have to hit this in reverse. So that means you folks would have to hit 0.9 and then e to the x. So let me show you that. So 0.9 first. Okay. And then second function e to the x, which is above the ln. I know you can barely see it there, but second function e to the x. So there it is. And then multiplied by 63. So times 63 equals 154.95. Okay, so if you have a modest scientific calculator, you folks would have to go backwards. So again, instead of e to the whatever, you have to put the number first, like 0.9, and then e to the x. Okay, so just experiment with your calculator until you get what you want, so to speak. Okay. All right, I'm done, folks. So the next thing I'm going to do is stop the share temporarily, but we're still recording. Check the chat. Okay, so exam is just from what we have here. Okay, so I will now let you ask questions. I'm done, folks. So you can ask questions for as long or as short as you want. The more questions we do now, the fewer we have to do next time. But that's up to you. If nobody has any questions, we're done. But again, I think, I'm guessing you want more time for the test. So we'll get more questions today.
I
Okay,
have
so
a
you can either
question.
put it in, the chat, or you can just unmute yourselves and tell me what you want. Okay.
Professor, you show us how to use the EDX calculator.
How to do
So,
E? Okay. Yeah.
Yeah.
What do you want me
How
to
do you do that?
How do you do it again?
Yes,
Yeah. Okay.
because
I'll
I
go
have a
over it.
different calculator like yours.
Okay. It should be somewhat close. Okay. Meantime, let's see. 11.2, number 25 was asked for. Okay. And let's see. Yeah. Those of you that joined late, please send me an email. I put away. Sorry. That's the way it works. Okay. Does anybody else want to tell me to do some problem? You can either unmute yourselves or put it in the chat. I have a request for 11.225 and a request for the calculator again. Okay, let me start with that. You can still put it. I just have to bounce back and forth go between, and yeah, we're still recording. Okay, so let me share the screen again. Okay, so almost every calculator that I know of for E works two ways. Okay, so E to the 0.9 that was there. Okay, so on this type of calculator, you can try it. If you literally go by order there, so E, so on my calculator, it's second function e to the x. Most calculators are like that, ln and e to the x on top. So second function e, okay? Now, my calculator doesn't come up with the left parenthesis. Some calculators, once you hit e, it automatically pops up with that. Okay, so if your calculator does it, then just close it with the right parenthesis. So 0.9 close parenthesis, like that. 2.45, whatever. Okay, and again, for those of you that have a backward working calculator, to get e to the 0.9, you folks have to hit 0.9 first. So 0.9, then second function, where to go? E to the x. Second function, e to the x, 2.45. So just check on your calculator. I'm guessing 99.9% of the calculators do one of the two. You either go just as written, e to the 0.9, or you go backwards, 0.9, and then e to the x. Okay. I can't imagine that there's calculators that does anything besides that.
Got it. Thank you.
All right, you're welcome. So just experiment with your calculator. Okay, 11.225 was asked for, so let me check that. But I better ask, 11.225 does it match? I think it does, since I think 11.225. So is this the question that you wanted?
Yes, that is correct.
That's correct? Okay, e to the negative 3x ln 2x. Okay, so let me write that down. So 11.225, y equals e to the negative 3x natural log 2x. Okay. All right, so this is a product group. First function, second function. F, G, as it were. So this is the product group. So again, you may go ahead and go back and put product rule, quotient rule, chain rule, put it on your cheat sheet for the test on Thursday. You're allowed to do that. Okay, so how does the product rule work? First function times the derivative of the second. So I'll put f g prime. So now I'm taking the derivative of ln 2x. So 1 over 2x times the derivative of 2x. What's the derivative of 2x? 2. It looks like the 2's are going to cancel out. So cancel, cancel. Plus g f prime. Second function, just copy it. Then I multiply by the derivative of the first function. So what is the derivative of e to the negative 3x? E to the negative 3x times the derivative of the exponent. So what is the derivative of negative 3x? Negative 3. Okay, and now it's just some cleanup. Let's see, 2's cancel out. This is going to be in the bottom. So I'll put that divided by x, e to the negative 3x over x. Is that right? And again, don't cancel the x's, right? You don't cancel an exponent with a non-exponent.
Professor,
Yes,
can you put e to the negative 3x at the bottom? Or
can I
no?
put it, so put it as 1 over x e to the 3x?
Yeah.
Yeah, that would be okay.
Oh, okay, thank
There's
you.
no need to, especially since they gave it to me like that. So if they gave it to me like that, you might as well just leave it that way. But yeah, technically you may move it now. Okay, this one, all you do is just move the negative 3 in front. And then, well, since they wrote it as E and then ln, I'll do it in order. So I'll go in the order. Yeah, I shouldn't have put a plus here. It should have been a minus, sorry. Minus 3 e to the negative 3x natural log of 2x. And that's pretty much about it.
Professor, where did the 1 over 2x come from? Where did the 1 come from?
Okay, so 1 over 2x. I'm taking the derivative of natural log of 2x. So taking the derivative of natural log is 1 over this thing. Right? Derivative of ln x is 1 over x. If you have ln of something more complicated, you go 1 over that complicated thing. Well, I guess 2x isn't that complicated, but it's 1 over 2x times the derivative of the inside, which is 2. Part of the chain rule.
Thanks.
Okay. So that is that. And check the chat. Yeah, I figured out how to do the chat now. I got to do this tricky thing here. That's that. Okay. All right, folks. Once again, I'm done. It's only about 6:30-ish. So if we have no questions and I have no answers, then we're done. But again, you might have questions. You know, it's better to get them out now rather than next time. Otherwise, you'll have less time to do the test. But you know, that's up to you guys. If you don't ask any questions on Thursday, then we'll just go straight to the test. But I'll let you ask questions up until, what do we say, 6 o'clock at the latest?
Excuse me, sir.
Yes.
On the second part of this problem, at the ending of the answer, ln 2x, how come you don't do 1 over 2x there?
I don't do 1 over 2x here, right? Because the product rule says for this part, it's the second function times the derivative of the first, not the derivative of the second function. You just copy the second function.
Okay, copy it. Okay.
Right. So copy the first, derivative of the second, plus copy the second, derivative of the first.
All right.
Right? So that's the way that goes. Okay, let me check the chat. I think I'm caught up. Okay, so any other questions, please? You may put it in the chat or unmute yourselves. Otherwise, we're done. And just prepare for the test on Thursday. Okay, so again, you prepare this stuff. You have your homework, should be from here, at least 70%. Okay. And yeah, and just, the semester's ending real fast, folks. Because after that, we have Thanksgiving holiday. We only have one exam left. There's only 4 sections. So if I do 1 section a day, we're aiming for the last test being on Thursday, the 10th of December, and the final exam's on the 17th, and then we're finished. Okay. All right, anybody else? Otherwise, we're done.
10.3, number 28.
Sure, 10.3, number 28. Let's take a look at that. Number 28. Show it to. Okay, does that match? Is this the question? Orlando, I think? Or anybody?
Yeah, no, on my end, it says if the profit function for a commodity is P 6400.
Okay, so my 26?
5600.
Yes, 26.
No, that's my 27. Yes, you're 26. Yes, sir.
26.
Okay,
Yeah,
so do
26.
my 26, which is your 28. Is that correct?
Yes.
Okay, I get it. So 10.3. I'm writing 28, but I'm doing my 26. Okay, so P is equal to 6400 x minus 18 x squared.
Is profit always initials with a P?
Yes, so capital P is for profit. Well, it even says so in the question, I guess. Minus 1/3 x cubed minus 40,000. Okay, so is this the question that you want in mind? This is it, right? So to make sure I'm not doing the wrong one.
Yes.
Okay. So how many units would result in maximum profit? Find the maximum profit. Okay, so we want to maximize our profit. So find the x and the amount. So this is almost like the question on the quiz. So P prime. So let's see, the derivative of 6400x is 6400. The derivative of this is 36x minus x squared. P double prime is negative 36 minus 2x. That's going to be less than 0 for all x greater than 0. If I plug in any positive number, this is negative. Okay, so on the graph, which I'm not graphing, but on the graph, it means concave down, which means if I have a horizontal tangent, I will have a maximum. So that's how you prove that we would have a maximum. Okay, it's a concave down situation. When the slope is 0, we'll have a maximum. It'll look like that. Okay, so I need to set this equal to 0. So 6400 minus 36x minus x squared equals 0. Oh boy, that's not very fun. Let me multiply both sides by -1 and write it in order. So the proper order is x squared plus 36x minus 6400 equals 0, like that. Okay, so I believe it's 164 x 164. 100 times 64 is clearly 6400, and they are 36 apart. Yeah, that's right. So that should be a plus, that should be a minus. So plus minus equals 0. If you can't factor, you can always use the quadratic formula. So x is equal to negative 100, which I throw out. X has to be positive. X equals 64. So this would maximize the profit. And then what is the maximum profit? I just plug in. Okay, so P of 64 is, plug in 64. Do you want me to actually plug that in, or can you do that on your own? So we can save time and do another problem.
Yeah, just as far as we need to get to.
Yeah, well, you do need to plug this in, but it's just a calculator now. So to finish the problem.
Okay, and you plug that into the initial question, right?
Right. So 64 goes here, 64 goes here, 64 goes here, but I'm not sure if I want to take up class time to do that.
Yes, okay.
If you don't mind. Okay, and your answer is going to be so many dollars, I guess.
208,490,066.
Oh, okay.
That's the answer.
Okay, that's fine.
Why did you multiply it by the -1?
I multiplied by -1 to make it an easier quadratic. Okay, first, I don't like to have a negative x squared. I like a positive x squared. That makes it easier to factor.
Okay.
It's way better than this. Just take my word for it.
Professor,
Yes.
so you also have to do the second prime,
Do I have to do the second derivative? I did.
the second derivative. Is that how do you figure it out to have concave down?
Concave down. Okay, so put this on your cheat sheet, by the way. Second derivative negative means concave down. That was one of the earlier sections. I believe it was section 10.2, if I'm not mistaken. My page 644, but
Oh, okay, got it.
sorry, I can't hold this book in acting. Right. Worst comes to worst, we're still recording, so it's in the recording. If you need it.
So if the amount is less than 0,
Right, less than 0. Second derivative means concave down, which means I would have a maximum when the slope is 0. And here's a little mini picture of it. Okay, concave down, upside down U shape. If the slope is 0, I'm at a maximum. Okay, if I have a concave up situation, that means second derivative is positive, then I would have a minimum. So y double prime greater than 0 means concave up. So when the slope is 0, I'm at a minimum.
thank you.
Okay, welcome. Okay, anybody else, please? Anything else? Okay, I don't hear anything, so we will quit then, folks. All right, so prepare for the test on Thursday. I'll let you ask questions on Thursday, but if not, or at minimum, go up to 6 o'clock and then we'll take the test.
Now,
And
can
then
I
we'll
ask you for the one last question?
Sure. Okay. Yeah.
Okay, it's the same chapter, number 29.
Uh, 10.3.
Yes.
And I have to determine if it's your 29 or my 29.
29 is a manufacturer. The 27, yours.
My 27.
Yes.
Okay. Do all the other numbers match?
Yes.
5,000, 40, and all that stuff.
Yes.
Okay. Well, I guess we're not finishing after all, folks. 27. C of X. Okay, I'm closing the chat window because it gets in my way. 45,000. This book is heavy. Plus 100x plus x cubed. Revenue is 4,600x. Okay, you want to maximize the profit. Okay, profit is revenue minus cost. So it's 4,600x minus parentheses, 45,000 plus 100x plus x cubed, which is, let me try to write it in order, negative x cubed, 4,600x minus 100x is 4,500x, minus 45,000. So 4,600x minus 100x, 4,500x. Okay, I think we're good.
How did you get 4,600?
4,600, that was the revenue. Unless I wrote it wrong. Yeah, it's 4,600. This was the revenue function. Okay, so P prime, negative 3x squared plus 4,500. P double prime is negative 6x. That's going to be negative for all x greater than 0. So again, that means concave down. Again, that means I will have a maximum. So I set the first derivative equal to 0 and solve, and that should do it. So set P prime of x equal to 0. Negative 3x squared plus 4,500 equals 0. Move that over. 4,500 equals 3x squared. Divide by 3, divide by 3. X squared equals 1,500. X is square root of 1,500. Square root 38.73. And then what is the maximum profit? You just plug in 38.73 to the P. So maximum profit is negative 38.73 cubed plus 4,500, 38.73 minus 45,000. Let me actually do that one. And I'm getting a syntax error. That's not very good. Try it again. Negative.
The answer is x is equals to 10 square root of 15.
Yes, but for this kind of problem, it's more appropriate to write it like so.
Okay. $71,000.
Answer is 45,000. 71,189.50. Okay. All right, anything else, folks?
Thank you.
Yeah, you're welcome. All right, that'll do it, folks. So we'll see you on Thursday for the test, all right? So everybody have a good night, and we'll see you next time. Okay, all right, bye, everybody.
Bye, thank you.
Thank you.
Thank you.
Bye.
Thank you, good night.
Thank you.